So in this video we're going to look at the sigmoid function, and then we're going to convert it into Python code to get this working. So this is just a definition, and it's straight from Wikipedia. It's a sigmoid function, and just from the definition on the side bit over here, a sigmoid function is a mathematical function having a characteristic S-shaped curve or sigmoid curve, which is this blue curve on the side. And a common example of the sigmoid function is the logistic function as shown in the first figure, which is the blue figure. And then we scroll down and we see that there's actually a mathematical function for it. So we can kind of like see this little function here. The sigma of x is 1 over 1 plus e to the minus x. And this is what we're going to effectively try to construct in Python. So in order to do that, I need to just hide this or move this little thing backwards. So let me move to bottom. Yep, there we go. It's out of the way. And we've now got our VS Code to work in. And what we're going to do is we are going to, first of all, create a function like this. So define a function, but the function that we want to define is going to have a name, and it's going to have the name sig for sigmoid, and it's going to take in a variable x, which is of type float, like this, and this is just a sigmoid function. We could annotate the doc string a bit better, but we don't need to for now, and just then say s equals 1 over and then something. Everything here inside the parentheses is the denominator, and what needs to go in here is 1 plus and then something else, and that something else is the exponential function to the power of minus x. Now, in order to get the exponential function in Python, there's a few different ways of doing it, but one way is to import the math module like this, and then we can do math.e. That gets us the exponential function. But actually, we want to raise this to the power of minus x like that. And then we can return our value of s. So that's basically the entire sigmoid function, all created in Python. Very simple. And we can actually now test out our function, so we can just do sig of 10, for example, and hit Control Return to run everything. It's opening up an interactive terminal, which might take 10 seconds to do, or 20 seconds, however long it does take. It's always nice when it's nice and slow. Once it's launched, it's fine. And there we go. We get sigmoid of 10 here, which is 0.999. And we could test it out and do another sigmoid. So we could, for example, put in 5, and then we see that sigmoid of 5 is 0.993, and so forth. But one thing we might want to do is put all of this into a for loop. So we could say something like for I in range, and then 10. And then instead of doing sig of a number, we could actually do sig of I. So we'll loop through each value from 0 to 9, because it's 10 minus 1. And we'll get all of the values, and we'll see them like this. How about printing it? So print. There we go, and we see that we get the numbers, and we might want to see, and what we see is it starts at half here, and then it goes and it approaches 1 slowly. Now, what we might want to do is just go over here and put in I for the index, and we can see that a little bit clearer, but it's still not clear enough. So we might want to put all of this into an F string just to make it nice and clear. And so something like this. And now we can see that 0 gives us a half, 1 gives us 0.73, we get something else, and 2 gives us, and so forth. And we can even annotate this to be .3f to 3 decimal places. And that's quite nice, and it's quite clear that way. We see that 0 gives us a half, and then it approaches 1 as the number gets higher, and in fact it does get to 1 at some point. And if we went up to like 20, we just get a whole bunch of 1s afterwards. So there would be no need to do any further. All of these become 1 because we basically approached 1. We're very, very close to the number 1. So the next thing to do is actually make it more symmetrical, and one way of doing that is going from -9 to 10, and that will give us symmetry. Remember that, okay, this number here is inclusive, this number here is exclusive, so we're actually going to go from 9 crossing through the 0 point, so the middle is actually 0, and then going to a number one less than 10, which is 9. So it's symmetrical around the 10 points. So we could just run it like this, and we indeed get -9. And we see that this approaches 0 at the negative side, and this approaches 1 at the positive side. And that's exactly describing the sigmoid function, but it's not possibly the clearest when we represent it in a box with strings like this. So the next thing that we might want to do is, and we can do this in Python quite quickly, so we'll import a module for plotting out charts. So import matplotlib.py plot as plt, and then we can start doing some attempts to charting. But the first thing we need to do is to get we will need to have 2 axes, so we need to create an x-axis and a y-axis. So we'll set 2 lists. One will be the x list and the other will be the y list. Now this isn't the most efficient way of doing it. There's way more powerful and faster ways of doing this, but this is quite simplistic and demonstrates Python's capability quite easily for for constructing things like this. Now what we want to do is just populate our list, so we'll do x.append. So every time we loop through the list, we're going to append our numbers, and we're just going to put in the values of I for x in there. And for our y list, we're going to put in the values of append, and then the sigmoid value, so sig of I. That's what's going to go in here, and we can then comment this out. So that's going to now populate these 2 lists. They're going to grow in size, and we might want to just observe that we actually get them. So we can do print of x, and we can also print y, and we can observe or just check that this actually works. So when we run our code, indeed, we get these lists that are created, and the top list just goes from -9 to +9. I might actually make this -10 to 11. There we go. So it goes from -10 to +10. That's the top list, and each one of these items here. So this item belongs at index at the first. So this value, this y value here, belongs to this x value, and this second y value here belongs to this second x value, and so forth. So now we've created our 2 lists. We actually just want to plot them, and the way to plot lists in using matplotlib is quite simple. We just do a plt.plot of x and y, and we might want to label our lists as well, so we do plot.xLabel is our x values, and then plot.yLabel is our y values, like this. And finally, I wonder if we can get a title in there as well. Plot.title is a sigmoid function. And finally, a plot.show to actually show the plot. So that's basically it. We've now created, over here we just pass in the x and y values, and then we've just given it some labels and a title, which is quite nice, and we can just run this in Python quite quickly just to show what we get. and indeed we get the sigmoid function that comes out of it. And I'm just going to go back and initially, or maybe I'll just mention this before I even go back, but we see that this is actually bounded, and we're going to see this in the definition. It's the asymptotes here are 0 on the negative side, and they are 1 here. They reach number 1 on the positive side, and in the middle, the 0 point where x equals 0. There's some point of inflection, and basically this function is a continuous function. So I'm just going to jump back quickly, if I can, to the move the top. Yeah, there we go. So that's just jumping back to the Wikipedia article, and what we see here in our definition as well, just so that we're clear on this, is a sigmoid function is bounded and differentiable. So bounded here means in mathematics a function f defined on some set of x. So really it's called bounded if the set of its values is bounded. In other words, there exists a real number m such that f is between m, but basically it exists within a certain region. That's what bounded actually means. And then it's also differentiable, which means that this line is never broken. So you never have to, the best description of it is you never have to lift your pen off the piece of paper to draw this line. It's just a continuous line. So that's what differentiable means. And that's basically it. What we've then done is produce a sigmoid function, and a sigmoid function and a sigmoid curve, which refer to the same object. That's basically it. And that's what we've actually created. And we've done it in Python in about 30 lines of code, quite simply, and it's demonstrated quite nicely for us. So that's pretty much it. I'll leave the video here, and we'll continue it at another section. So thanks for watching. If you did like it, if it was useful, it's a sigmoid function in Python. It's good for AI. Hit the thumbs up, hit the like button, hit the follow button. And if you've got any comments, by all means put the comments in too. That's it. Sigmoids.